guys. We're starting our Pythagorean theorem packet. So before we start talking about what the Pythagorean theorem actually is, let's review real quick where the hypotenuse and the legs are in a right triangle. So we've done this before when we've talked about hypotenuse leg theorem when we were proving triangles congruent. So this is just like a little refresher. So for number one, let's take a look. We know we have our right angle box in our triangle. So the hypotenuse is the side that is across from the right angle. So the side that is across from the right angle is right here. Remember, the hypotenuse is also the longest side in a right triangle. So this is our hypotenuse. I'm going to abbreviate it HYP. And the other sides are just our legs. Leg, leg. So really all we have to do here is find out where the hypotenuse is. So number two, across from the right angle is our hypotenuse. All right, we'll label it hypotenuse, and the other sides are just the legs. Let's do number three. Across from the right angle is our hypotenuse. And the other sides are our legs. Last one we're going to do together. The side across from the right angle is the hypotenuse. All right, HYP, hypotenuse, and the other two sides are our legs. All right, that's the last one we're going to do together. The other ones you'll finish on your own when I post your assignment. Now, on the next page is the real Pythagorean theorem notes, but we needed to know how to identify where the hypotenuse and the legs are in order to help us do Pythagorean theorem. Okay, so in Pythagorean theorem, it is only used with right triangles. No other type of triangle can use Pythagorean theorem. So it's only with right triangles. All right, so like we did on that first page, let's identify where the hypotenuse is. It's across from the right angle. So this is our hypotenuse. I wish I could trace a little better there. That's our hypotenuse, and the other sides are our legs. So when we do Pythagorean theorem, it has something to do with our leg and our leg and our hypotenuse at the end. But here's what happens. Whatever number is here with this leg, we take it and we square it. And then we take the other leg and we square it, and it's equal to our hypotenuse squared. But notice that plus sign in the middle here. What Pythagorean theorem is our leg squared plus our leg squared equaling our hypotenuse squared. But they've made it a little bit easier. This is another right triangle. So let's identify where the hypotenuse is. That's right across here. So instead of labeling it leg, leg, and hypotenuse, they've created a little formula that uses A's, B's, and C's. All right? C is always your hypotenuse. So I'm going to put hypotenuse in parentheses. C is always the hypotenuse. A and B are either leg. It does not matter where A and B go. The only place where it really matters where it goes is that hypotenuse. Hypotenuse has to be C. So I'm going to put an A here and a B here. If you put an A here and a B there, you'd be correct. The only thing that has to be C is that hypotenuse. So here's what I want to show you. It is the same formula up here. It's leg squared plus leg squared equals hypotenuse squared. But instead of using the words, we're just going to use our letters. So A is really a leg, so I'm going to do A squared plus B is really a leg, B squared equals my hypotenuse squared, which is really C squared. So I'm going to bubble that. A squared plus B squared equals C squared is the formula for Pythagorean theorem. You'll see it over and over when you do a standardized test and they give you some formulas. This is what they would give you. A squared plus B squared equals C squared. C squared is always the hypotenuse. Always has to be there at the end. All right, so let's see this in action. All right, we're going to do a couple of them, all right, and then you'll have some practice for homework. So, first let's figure out what we're finding. Are we finding out a hypotenuse or a leg? So in number 1, it looks to me like we're finding out the hypotenuse, all right? That is across from the right angle. So I'm going to label this as my hypotenuse, and my hypotenuse I know is C. All right, 5 and 12 are my legs. So what I want to do is I want to write my formula down. I do this every time that I do Pythagorean theorem. I write my formula down. A squared plus B squared equals C squared. So you don't want to write too big. You want to give yourself a little bit of room here. So A squared plus B squared. So I can pick whichever number I want to put in their spot. I'm going to do 5 squared plus 12 squared equals C squared. C is X. That has to come at the end. All right, so now it has to be calculator time. All right, so we know that 5 squared. So 5, this is our squared button. All right, some of you can do that in your head. That's fine. 5 squared is really 5 times 5, but let's utilize that squared button on the calculator. So 5 squared is 25 plus 12 squared is 144, and that equals X squared. All right, so now what we have to do is we have to add 25 plus 144. 25 plus 144 gives us 169. 169 equals X squared. Now, some of you might think, oh, we're done. But the problem is it doesn't say what is X squared, it just wants to know what X is. So the way that we undo a square is we have to do the square root. So if we do the square root on both sides, all right, so let's look at our calculator. Our square root button. What that does, that square root and the square end up canceling each other out, and you're just left with the X. That's the reason we're doing this. We're undoing that square. So then we use this in our calculator and we say, oh, the square root of 169 equals 13. So what you really found out is that this length, that red length, is 13. And does that make sense? 5, 12, 13. Isn't our hypotenuse always the longest side? Yeah. If you did this and you ended up and you said this was 9, you know you made a mistake somewhere because the hypotenuse always has to be the longest side. All right, let's take a look at number 2. Looks like we have to find out what X is. And X would be my, across from the right angle, that's my hypotenuse. So that's going to be my C. So I know that X has to come at the very end. So let's set up A squared plus B squared equals C squared. 7 and 8 can go in either spot. 7 squared plus 8 squared equals C squared. So 7 squared is 49. All right, we'll do that on the calculator. 7 squared is 49. All right, I'll get rid of that. 8 squared is 64. And that's equals C squared. So let's add 49 and 64. 49 plus 64 is 113. Equals C squared. Like we did in the other problem, take the square root, take the square root. That cancels out. So C equals, so the square root of 113 equals, we get a decimal this time. No big deal. Just round to the first decimal place, 10.6. So C equals 10.6. What you just found out was that the hypotenuse is 10.6. Now, if you notice in this one, I kept this as C, and over here I used an X. It really doesn't matter. I just kind of forgot to change it into an X. No big deal either way. All right, let's take a look at number 3. All right, so number 3, we've got to figure out looks like we have to figure out our hypotenuse again. And our hypotenuse is really C. So let's set up a squared plus b squared equals c squared. All right, 4 and 3, doesn't matter which one. 4 squared plus 3 squared equals c squared. Change it to x squared, it doesn't matter. 4 squared is 16. 3 squared is 9 equals c squared. 16 plus 9 is 25 equals c squared. Take the square root. That cancels out. When we do the square root of 25, we get 5. So C equals 5, because 5 times 5 gives me 25. Okay, so we are going to stop right here. In our next video, we're going to continue with Pythagorean theorem, and that will continue with when you have to find out one of the missing legs instead of the hypotenuse.